massive growing weak spot in Earth's magnetic field is about to split in two. This is what NASA explains concerning the South Atlantic anomaly. Geologists began expressing concerns about the magnetic field of the Earth. It shields our Earth from deadly solar radiation. And when the U.S. National Oceanic and Atmospheric Administration was forced to update its world magnetic model a year earlier after finding that the magnetic North Pole was rapidly moving out of the Canadian Arctic and towards Siberia. This is some of NASA's explanation concerning the solar radiation in Earth's magnetic field and the South Atlantic anomaly.
A weak spot in Earth's above South America, a weak spot in Earth's magnetic field is evolving. Called the South Atlantic anomaly, this unique region has been expanding for more than a decade, and scientists believe that it's beginning to split into two distinct zones. Now, while this anomaly poses little risk to life here on Earth, it does allow scientists to study the complicated mechanisms behind Earth's magnetism. Around 1,800 miles below the surface, dynamic processes in Earth's liquid iron outer core are continuously generating electrical currents. This accounts for the majority of Earth's magnetic field. But unlike a typical bar magnet with one north and south pole, Earth's magnetism isn't all neat and tidy. If we take a look below the anomaly at the boundary separating the core and the mantle, we can see the magnetic variations are much stronger. This picture provides a clear link between the anomaly we see in Earth's magnetosphere, its origins deep within Earth's interior, and how it's projected to evolve in the near future. This is important to understand because our planet's magnetic field plays a huge role in shaping the near-Earth environment. In addition to guiding compasses and animal migrations, the magnetic field acts like a shield, repelling charged particles flowing from the sun that could be disruptive if they reached the surface. Many of the particles that do slip inside Earth's protective bubble become trapped in large rings of energetic particles called the Van Allen belts, which are held in place by Earth's magnetic field. The inner edge of the innermost belt is about 400 miles from the surface of the Earth at the equator, which keeps particle radiation a safe distance from Earth and orbiting satellites. But because of the offset between Earth's magnetic and rotational poles, and the weakened magnetic field over the South Atlantic anomaly, some energetic particles within the belt do penetrate closer to the Earth's surface. This means that NASA and other space agencies need to account for the extra radiation when low-orbit satellites pass through the anomaly. Currently, NASA researchers are using data from satellites along with theoretical models to track the evolution of the South Atlantic anomaly and help prepare for future challenges to managing satellites and humans in space.
The U.S. National Aeronautics and Space Administration is tracking an immense growing and slowing splitting dent in Earth's magnetic field. The area, as we know, is the South Atlantic anomaly, situated in the southern hemisphere between South America and the southern Atlantic Ocean off the coast of southwestern Africa. According to recent NASA monitoring and modeling, this area is expanding west and becoming weaker and expected to completely split into two separate cells, each spanning thousands of miles across, and it will happen soon, they said. NASA says the weakening of the magnetic field in this area threatens to allow more solar radiation to get closer to the Earth's atmosphere, thus disabling electronics or scrambling or temporarily disabling satellites and other space-based man-made objects, such as GPS, for example, or cell phone transmissions, objects that pass through it. In modeling running through to the year 2025, NASA predicts that the Southern Atlantic anomaly will continue to grow, with the larger of the two globes continuing to spread over central South America and the smaller remaining off the southwest coast of South Africa. Earth's protective magnetic field is generated by a number of factors, the most important being the churning of liquid iron flowing inside our planet's core, and that creates the electrical current sent outwards into near space to create the Earth's magnetic field, the magnetosphere. It's believed that a massive reservoir of dense rock known as the African Large Low Shear Velocity Province, or African superplume, causes a disturbance of the field's generation, resulting in a regional weakening of the Earth's magnetic field. A second massive superplume is located under the Pacific Ocean, northeast of Australia. Scientists still have much more to learn about the South Atlantic anomaly and the implication it may have on our human civilizations. Last month, for example, scientists from the University of Liverpool Geomagnetism Laboratory discovered that the South Atlantic anomaly has likely been around for millions of years by studying volcanic rocks from the remote South Atlantic island of St. Helena. Last year, the rapid shifting of the coordinates of the magnetic North Pole out of the Canadian Arctic toward Siberia prompted some scientists to express concerns that Earth could be in for a flip or a flipping or a shifting of its magnetic north and south poles. The last such flip is thought to have taken place around 780,000 years ago, and scientists still don't fully understand how such a phenomenon would affect the magnetic field of the Earth. Even with the magnetic field intact, human civilizations remain vulnerable to sudden bursts of powerful solar radiation. In 2011, U.S. academics warned that a repeat of a solar storm similar to that which hit our Earth in 1859, the Carrington event, could cause as much as $2 trillion in initial damage, damaging electrical power grids, satellites, navigation systems, etc. Of course, the power grids are the most important, but others have sought to calm fears of a flip, estimating that such a process may take as much as 1,000 years to complete, so dramatically reducing its negative impact. This is by NASA's explorers exploring Earth magnetic Dent. The film is Creative Commons, as we know, and it's on Sputnik News. Please leave your comments. Thank you for your support. And if you'd like, please support my Patreon channel. Thank you so much. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.